Yeah, we should do it next.
You can't, I don't want to see it.
Okay.
Everyone agrees with me because I just made a good point.
The related rates, shadow problems. This is really the last category that we'll do. So we have a man 6 feet tall, walks at a rate of 5 feet per second away from a light that is 15 feet above the ground. So here's my light, 15 feet above the ground. And a man who's 6 feet tall, okay, is walking at a rate that's 5 feet per second. So, are we good with how, if this is the light source at the top, I'll just make it a sun. Like the shadow kind of gets made because it, you know, hits the top of the person's head, and then that person and below kind of blocks the sun from hitting the ground. So his shadow would be this long, right? Yeah. So this is the length of his shadow right now. But he's walking out, so this is what's changing. As he walks, this is increasing at a rate of 5 feet per second. So I'm going to call this x. And so dx dt is going to equal 5. When he is 10 feet from the base, so when x equals 10, at what rate is the tip of his shadow moving is part A. So at what rate is this moving? And also for part B, at what rate is the length of this shadow changing? So I'm going to call this y, and this will be dy dt. So y is the length of the shadow. Are you with me there?
Yes.
X is the distance the guy is away from the light source. It actually, does it make more sense? I think it actually makes more sense to do this one first. At what rate is the length of the shadow changing? So let's first kind of figure out what's going on here. So we have, what do we have here from geometry? Similar triangles. So at the moment that this is 10, let's figure out what y is. So we would set up a proportion, 6 over y equals 15 over what? No.
X plus y.
X plus y, correct. Which could be 10 plus y, because we're looking for y specifically at this moment. So when I cross multiply, I get 60 plus 6y equals 15y. Subtract 6y from both sides, 60 equals 9y, and y equals 69. Now, x and y are not constants, right? They're changing. They're both changing. The guy's walking away, so this is obviously growing. And as you walk away from a light source, what happens to your shadow?
It gets larger.
Let me ask you this. Is your shadow longer at noon or at 7 p.m.? Right, because the sun's like further away from you and lower in the sky, right? So as you walk away, there's a couple things changing here. Obviously, this is growing, but on top of it, this is growing. Yes? Maggie?
Should you simplify the 69 or should we just leave it?
We can simplify it. Both divisible by 3. Good idea, 20/3. Okay. So they want dy dt. So we need some formula that's going to involve x and y. That's really the only option we have here. Okay? And we have that formula, it's right here. But we can't use the 10. So I'm going to go back and rewrite that. 6 over y equals 15 over x plus y. And the reason we can't use the 10 prior to differentiating is because it's not a constant. We only use the 10 momentarily to figure out what the y value was going to be at the moment when the x value is 10. So I'm going to cross multiply 6x plus 6y equals 15y. And I'm going to get 6x equals 9y. And that's what I'm going to differentiate. So my left side is 6 dx dt. And my right side is 9 dy dt. So we know that dx dt is changing at a rate of 5, so we'll just plug that in, and we'll find dy dt. Divide both sides by 9, and we get dy dt equals 30 over 9. So reduce by 3, 10/3. What are we, feet? So everything's feet per second. So, looking at your two questions, we pretty much have everything. We've done all of our calculations. We have to answer the questions, at what rate is the tip of his shadow moving, and at what rate is the length of his shadow changing? It's not. It's not. The length of the shadow is the dy dt. The length of the shadow is just the dy dt, and that's the rate at which that's changing. So that's part B. So 10/3 feet per second. With the rate at which the tip of the shadow is moving, there's two things playing into that. Number one, he's walking at this rate. So the tip of the shadow has to be moving by at least the same rate as the rate he's walking. And on top of that, as he's walking, the shadow is also growing. So the tip of the shadow itself is actually moving double. It's moving once strictly due to the fact that the guy's walking, and a second because the shadow is growing as he's walking. Yes? So it's kind of a double whammy there on how fast the tip of the shadow is moving, and for that we would just add these two together. Okay? It's definitely moving at that rate of 5 feet per second because the guy's walking, but it's also growing, and so it's moving that additional amount per second. So if you wanted to, this is 3 1/3, so in total it's moving 8 1/3 feet per second. So be careful on these, what they're asking for, and be careful to fully understand what each of these rates of changes are. This is the rate he's walking, this is the rate at which the shadow is growing, and so we kind of combine those together to get the tip of the shadow and how fast the tip itself is moving. Versus if we just want the rate of change of the shadow, that's just this part. Does that make sense? Okay. On the second example, we're assuming that it's the same guy from the previous problem is moving instead toward the light. So, similar picture. With your similar triangles. But instead, your guy is walking towards the light at the same rate that he used to be walking away from the light. So dx dt is now what? -5. And we're still looking for, at the moment that he's 10 feet away. So our y coordinate is still 20/3. And we're searching for dy dt. And then we'll answer the questions in a minute, but similarly, when we set up our equation that we're going to differentiate, we get 6 over y equals 15 over x plus y. And then we cross multiply. So 6x plus 6y equals 15y. I'm going to get all my y's together and then differentiate. 6 dx dt equals 9 dy dt, which obviously you're seeing is exactly the same thing so far that we did the last time. Now though, dx dt is -5 instead of +5. We divide both sides by 9. And so the only thing that's really changed is that everything seems to have been negated. So now because he's walking back towards the light, the length of his shadow is shrinking, and it's just negated from what it was before. Okay? So when we're asked for the rate for the length of his shadow, that's the -39. So the length of his shadow is shrinking at that rate. The tip of the shadow, again, is moving backwards. It's like a double whammy again. It's moving backwards because the guy is walking, and that naturally is bringing the shadow with him. And because he's walking towards the light, it's also shrinking the shadow. So we've got the -5 combined with the -39, and it's just going to be a -8 1/3 feet per second when you combine -5 and -39. So just kind of, you are going to come across problems where the shadow, you're walking away from the light, you're walking towards the light. So understanding, really at the end of the day, there's no difference other than negating everything.
We're done.
We are done.
Are we actually like done?
Well, no, you're going to start your homework.
Wow. This is unbelievable.
Now your homework is kind of a combo. There's shadow problems in there, but there's also some triangle and volume type questions. So I guess the first thing I want you to do is read through these, and if something seems unfamiliar to you, like, wait a minute, we've never done one like that, let me know and we can do it together. Okay? Oh, it's a great idea.
Oh.
Wow, I said it earlier.
That would be 20 minutes.
Yeah. Show us.
Show you, I'm thinking, why don't I need to do corrections?
Oh.
I'm gonna hear me out. No.
I can't, 20 minutes is not going to be enough. You know what, I'm just going to give them back, and it's going to be the typical 20% type of correction.
Okay.
We got all these?
Just because I don't think we have time to do that.
No.